So, there are some left there for transformations that are just a little bit harder to translate. Did we have more, could you read more? What other types of transformations did we have listed there? Because I want to get all this out of the way if I can.
Horizontal stretching and
Okay, hang on just one second. Let me set this up so I get it nice here. Let's get this out of the way. Transformations. Shifting and so forth and so on. Now she's telling me, hold on, Professor. You have not shown us one yet, and she's gonna read it to me. What was that?
To graph f of cx,
Okay, f of cx. Okay.
c is greater than 1.
Uh-oh, c is gonna be greater than 1.
Shrink the graph of y equals f of x horizontally by a factor of 1 over c.
Oh, Lord. By a factor of 1 over c. Now, did Ramsey create these transformations? No. This is the way it was presented to me way back. I didn't create these. This is what we accept. Now, if I read that as a student of my math text and try to make sense of what does that mean? It means something a little different. We're going to take a look at it. Read the next one to me and I'll be ready for it.
To graph f of cx,
Okay.
where 0 is less than c and less than a.
Less than 1?
Yes.
Like that? Okay.
Stretch the graph of y equals f of x horizontally by a factor of 1 over c.
Stretch by a factor of 1 over c. Now, I think she said stretch horizontally, not vertically. I think it's on your handout there. Ooh. Are there others there to be listed, or did I stop with that? I stopped with that? Now, all I can do for you guys now is I'm gonna do one of those on the back. Bear with me. Did I have a graph drawn for you already on the back? I'm gonna set that as my parent graph. Then I'm gonna try, here it goes, don't get too aggravated. I'm gonna take that parent graph, it's a graph that I gave you as a parent graph. You have not seen this particular graph before, but I'm gonna accept it as my graph that I'll be working with. Now I'm gonna start applying some of these transformations on it. Now there's one that would take a little time, I may not get to it. There's a couple I wanna point out here. Bear with me. I need to point out the best I can. Based on that graph. Let me check. Let me see if maybe a second. Okay, guys, we're talking about this. I had it out -4 down 2. I'll be very careful with this. So sort of finishes up. -4 down 2. Right there. Then it looks like it goes up to 2 on the y-axis, not on the scale. And 2, 2 over here. And then it looks like 4, 0. That's here. I think I have all my points I need. Okay, here we go. Connect those, thank you. And your graph that was given on the back there looks something like this. I'll get out of your way here, you can see it in the back. Guys, I think, is that close enough to what you guys see on the graph? The graph, pretty close to that? Now, on the back, let me check one more time. I have 4 grids, and I'm asking you to take that parent graph and apply these transformations on and get 4 graphs for me. Me, your instructor. I see 1, 2, 3, 4. Guys, I'm gonna do, oh my goodness. let's jump down to number 3. F of x is equal to, or y is equal to f of 2x. You know, and I'm asking you to try to apply that to this graph. And she gave me, just a few seconds ago, transformations. And guys, if I try to match this up with what was given to me, it looks something like this for sure. Cx as 2x. And I think she gave me if c is greater than 1. And my c in this case is 2. So it's greater than 1, so I should be doing this to it. So what should I do? I should try to shrink this graph, shrink it, by a factor of 1 over c. So when I finish up, if we do things correctly, this graph that you see on your handout should now shrink in horizontally, like this. But retain its shape, which is shrunk horizontally, not this way. This is vertical shrink. This is a horizontal shrink. Now, can anyone tell me what would I do you think, with those, I think I have 4 points labeled. What can I do to be clever with those 4 points to get that graph to shrink for me horizontally? Go for it.
Multiply them by half.
Multiply what by 1/2?
X value.
Thank you. He said, wait, Professor, she tells you to do this. Shrink it by a factor of 1 over c. And my c in this case is 2. So go through and multiply each one of those x coordinates for these points. This x coordinate, this x coordinate, this one, by 1/2. By the way, I didn't label this one, guys. I think it was -4 down 2. Make sure I have that copy down correctly. I think everything else is pretty obvious what it is. So guys, here goes. Thank you for your help here. This now becomes, if I multiply the x coordinate by 1/2, based on what's read to me, this becomes what now? -2 down 2. So it's -2, we'll put that right here. Find it, squeeze that in. In other words, it's now here. My next point was here, which is 0, 2. If that would help to label the point. Well, I'm supposed to multiply the x coordinate, right here's 0 in this case, by 1/2 again, which means that point's going to what? Stay where it is. Is 1/2 times 0 still 0? So if I multiply the x coordinate by 1/2, is that true? So is that point going to stay right where it is? Here. Must be blue there, guys. Over here is 2 up 2. And if I multiply the x coordinate by 1/2, whatever c, it now becomes 1, 2. So please, if I plot out 1, up 2, please tell me, is that now here? Yes or no? And my last one is 4, 0. If I multiply that x coordinate, which is 4 by, what, 1/2, I get 2, 0. So I'm here. So guys, I got a blue point here, blue point that overlapped here, another blue point here, and a blue point there. Might look black to you guys sitting back there. Now let's connect those. I'll connect them in the order I see them. So now it goes up like this, over like this. I'll make it look as best I can, and then down. Step back, and you guys see that pretty well. Compared to the original black graph, does it look like it's been shrunk, squeezed in? And that's all she told me to do. So I multiply all those x coordinates by 1 over c, and that's going to force that black graph, the parent graph, to shrink for me. And now, by the way, the shape is retained. Same shape, just been shrunk in. That's what this means. If the c falls between these two numbers, 0 and 1, I don't think I have 1 on the handout where that happens. If the c falls between 0 and 1, it's going to be, again, 1 over c being used. It's going to be stretched by a factor of 1 over c. Make sense, guys? So I'm looking at there. So I did that one. Now there's one more, and I'm going to leave the hardest one for you guys. do? Which one do you think, before I get to my last one here, which one of those four of you think your professor's gonna leave for you to do? Number two. Number two, we have to show each transformation. You get the graph of number two. Okay, I just did, guys, number three, number four. I'm doing the easier ones. I like to take that same graph if I can now, and let's put this, where is it? I'll put it on the side here. Y is equal to, I think it says this, see if I'm correct. Show the graph of that. Now, this is not truly a transformation, but it's going to change something. But in a sense, it is transformation. Absolute value f of x. Now, you know what absolute value implies. So what do you think that means for me to do to this original black graph to get what the absolute value of that function is? Anyone? Okay, hand one up, yes.
Flip the line that goes to the negative.
Okay, now when you say flip, hang on, we'll do it, hang on just a second. But tell me in the raw form you see right now, looks like this, and knowing what you know about absolute value, what might you tell me to do up here with those points? We'll move it to the points. What might you tell me to do here, with that point, and I think we have another point over here, on the original black graph, to show what absolute value has done to this graph? What do you think I'm after? What should you do with those 4 points? It says take the absolute value of f of x. Go for it.
The absolute value of the y value.
Love it. F of x is like y. Just go through those 4 points and take the absolute value of the y coordinate only. Well, if I start with the original point here, trying red here, guys. The first point, negative 2 is the y. He says, Professor, take the absolute value of that. But it turns into a positive 2. So now it's negative 4 up 2, it's now up here. Don't we mess up. Next point, I think, was here at 0, 2. You take the absolute value of the y, he says the y now, which is a 2. The absolute value of 2 is still 2. That point's going to stay where it is. If you guys agree. Next point, I think, I don't want to mess up here on the black graph, was what, 2, 2? So if you take the absolute value of the y coordinate, which is 2, does that point also stay where it is? Down here. Finally, I get 4, 0. Not too exciting. 4, 0, take the absolute value, does it stay right where it is? Are you kidding? Now what's going to happen here when I connect? What can we connect? Did we leave anything out, guys? He said take the absolute value of the y coordinates. Now I think the absolute value of the y coordinates correctly. Now if I connect them, see what that shape looks like. Should resemble somewhat, well, except the absolute values implied, the original black graph, I guess. Any ideas? Anyone? This point now is up here. I gotta be careful. I need some help. Need some help. By the way, do you agree with those points we have already plotted? Those points in red, I'm using red here. This point should be up here, this point stays where it is, this point stays where it is, and students are telling me, Professor, this point stays where it is. Is that true? So let me do this to make sure. We are saying that stays where it is, Professor. That stays where it is. Stays where it is. This one, with his help, moves up. Now tell me, what should I do? I realize those points are correct. And also you're looking at the original black graph, let's look at there. We're trying to show what does absolute value do to the graph, the black graph. Now right now, I would be tempted if I were a student, say, Professor, connect here to here, and you get a nice little straight segment. And then connect there. so? You think that's what it means? Connect all this across, showing this, to this, to this, to this, and professor call it quits. That's the absolute value of that function. Oh. See a hand going up. Yes? Oops, either one of you guys.
I flipped it when it crossed the y-axis. So like when it starts, when it hits 0, I have it flip back up.
Hang on now. So are you telling me on the black graph now, this piece right here, this piece,
Yes.
is below the x-axis? Is that true? The original graph, it's below the x-axis from here to here. He says, Professor, if it's below the x-axis, this little segment here on the original graph, that implies it's negative. If you take the absolute value, it should turn into what? Positive. That means that this little piece here should be above the x-axis. Now, where is it? Is it this? Is this little piece now going to be flipped over and like that? Or not? Is that what you're telling me? Are you telling me, now hang on, are you telling me it looks more like, let me do this, this little piece here now looks like this? If I flip it across the x-axis, make it positive? I think students are telling me that, right? Now may I connect these two and be safe about it? Let's see if I can look at it. Yes or no? Could I connect these two? Is this part of the graph right here? Because I see this piece right here, the black, I got that above the x-axis. Oh, by the way, the original black graph that's on your handout, is this the only piece that was below the x-axis? So I got it now where it should be above the x-axis. I think the absolute value. Guys, was everything else okay, or is there something wrong with it? We got this up here, then what else? What should that have done to my graph, the original black graph? Or is that it? I need some discussion on this one. Is this right here, this red, this to this, out there, this, is that the graph? Or not? Somebody's shaking this, Professor, I think it is. From here to here, Mr. Park, June, connect. Whatever you're here. They're telling me if you take the absolute value of the black graph I had on the handout, it might look like that. You guys agree? By the way, tell me one thing. Is all of the black graph now above the x-axis? Is all the black graph been moved above the x-axis? And that's what absolute value is, positive, so it should be above the x-axis. Now, I heard one of my clever students say, Professor, another way to do it would be, you gave us, I think the student in the back there, you gave us this definition for absolute value of x in two pieces as this. I'm just throwing this out here just to think about it. So he said, in his mind, he was sort of doing it, I think, something like this. Yeah. On this graph, thinking this piece should be positive, this is negative, and then run through it. You okay?
No, I'm really sick.
You want to know?
No, I don't really miss
Okay. Now, would you guys agree? And I could have used, as he did, I think he thought about the absolute value what it meant. But now, would you agree, no matter what, is that red graph sure enough representing the absolute value of the black graph? Yes or no? And I think June and Mr. Park, I think you guys are saying it is. The absolute value, right? Everything's above the x-axis. Now, that's the trouble with transformations. And you're going to have some difficulty with the one that's left for you to try. Read that F of, how would you read it? F of 2 minus x?
Minus f
mine's not out front?
Yeah,
And mine's 6.
I have 6.
Oh, my, is that the one we were sort of talking about earlier? Was it? Or not? Did we actually do this one?
Yes.
Oh, geez. Okay, then, okay. Absolutely.
Oh.
Send me an email later on if you feel like it. So guys, pretty much done there. Transformations, as far as we're concerned, transformations for the most part is done. That's 1.5, I think, was it? Yeah. Now, I'm saying time goes by fast here. I know I'm doing, again, a lot of the talking, like a lecture. I like my students to participate too. We're just not to that point yet where we have all that participation coming up. There'll be times where we have to, probably work in little groups and do some participation. But I don't have the time right now to get to the point where I need it. Guys, we're closing down chapter 1. Thank goodness, Professor. Chapter 1's done, let's move on. I want to do some trig, Professor, I want to do some trig. The trig for this course does not start till chapter 5. And then 6. And then 7. The author of the textbook devotes 3 chapters to trig. So when we get to trig, it's going to be fast, but 3 chapters. Okay? Here's what I want to close in. I'm not going to be able to do all this today, but I think it's going to help you to see what I am going to hold you responsible for. This is section 1.5, and then on the back is 2.3. We may not get there today. 2.3. We're going to try our best